Everybody, it's Mrs. Mancuso, and this week we are still doing redox reactions, but now we're going to focus on are they spontaneous or not. So let's do a redox reaction first. Let's say we have FeCl3 plus gold, Au, and that would form AuCl because Au is a +1 and Cl is a -1. And then Fe would be all on its own, which makes it have an oxidation state of 0. I go back here, the Fe must have been a +3 because I see that it crisscrossed down here to the Cl, and Cl is a -1, and Au is a 0 because it's alone. So oxidation is when it loses electrons. Oxidation is losing electrons. So you can go ahead, do your arrow, and show that you're going to have plus electrons at the end because you're going to lose electrons. When you are oxidizing, your oxidation number goes up because if you lose a negative, you become more positive. So I look up here, my Fe is going from a +3 down to a 0, so that's not oxidation. My Cl is a -1 before and a -1 after, which means that's my spectator ion. That did not change. And here's what changed. Au was oxidized. It changed from a 0 to a +1. Oh, and now I'm noticing I better balance this before I get started to make sure that I have equal number of electrons lost and gained. So if I have 3 Cl's on this side, I would have to make this a 3 and this a 3. Okay, so if I start off with 3 Au's and they become 3 Au's at +1, that's a change in charge of 1 times 3 atoms. That would be 3 electrons lost. All right, now the reduction half reaction. Reduction is gaining. So if I'm gaining electrons, I can show the plus electrons before the arrow because I have to add those electrons in. Reduction's oxidation number goes down because if you gain electrons, you're gaining negatives, so your charge will decrease. So that's Fe. So Fe at a +3 becomes just Fe. So it's changing by 3 times 1 atom, so that's 3 electrons. So what I have just done is gone through everything you've already learned, what oxidation is, what reduction is, how to balance an equation, how to write out the half reactions, and identify the electrons lost and gained. What we're going to do now is we're going to talk about if a reaction is spontaneous. So spontaneous means that it will occur without the input of energy. So I like to think of this as it happens all on its own. So if reaction is spontaneous, it happens all on its own. So let's think about what happens normally. If this is my periodic table, and here's my staircase, over here, left side losers. So when something loses electrons, that's oxidation. Oxidation is losing. So my metals are the things on the left side of the periodic table. So metals oxidize. Metals lose electrons. And when they lose electrons, their oxidation number goes up and they become more positive, which is why you see all of the metals over here have positive oxidation states up in their top right-hand corner for what is most likely for them to become when bonding. Over here on the right side are my nonmetals, and they are most likely to undergo reduction because they gain electrons. Now, I'm going to leave out my noble gases because noble gases are not going to oxidize or reduce. They are unreactive. But over here, all of these things have negative oxidation states as they're most likely. So it is very spontaneous for a metal to oxidize and a nonmetal to reduce. Let's look at table J. Table J is called the activity series, and this is basically a ranking of metals on this side, nonmetals on this side, and it tells you most active all the way down to least active. So on the left side here are my metals, and so these are the most likely to oxidize. So I want to spend a little bit of time only looking at the left side. If you have a reaction involving two metals, so let's write out a reaction. Let's say K plus HCl would make KCl plus H, and hydrogen's never alone. It's one of those diatomics, so I got to put a 2 on it, which means I'm going to have to go back here and balance it and put a 2 there, which gives me 2 Cl's, so I need a 2 there and a 2 there. Okay, my K is at 0 and it goes up to a +1. So my oxidation is all about the K. My reduction is what's going down. So the H started at a +1 and went down to 0. To know if this is spontaneous or not, I don't have to write the half reaction right now. What I have to do is figure out if it's spontaneous. So to be spontaneous, the metal that is being oxidized needs to be higher on table J. So I'm going to look at table J and I want K to be higher than H. So I go over here. Here's K. Here's H. So yes, this reaction here, yes, this one is spontaneous because the metal being oxidized is higher than the hydrogen, which is being reduced. Let's do another one. Let's do Fe. Actually, let's go back to the first reaction that we did. Here, for this to be spontaneous, I need Au to be higher than Fe. So let's look over here. Here's Au. Oh, definitely not higher than Fe. So this one that I did first is not spontaneous. It is not likely for gold to oxidize. So I want to go back here to my chart and I want to talk about how this relates to things that you know, to metals that you know. First of all, a metal like Li. A metal like Li, lithium, is used in batteries that need a lot of power. So your cell phone battery, and if you have a really nice camera, your camera battery is a lithium battery, which means it is very likely to oxidize. It is a great oxidizer. It will provide a lot of energy by doing spontaneous oxidation. Now look at the bottom one, Au. That's gold. Where's the most common place you see gold? In jewelry. And jewelry does not oxidize. Well, gold jewelry doesn't oxidize. If you went to Claire's and you bought some really cheap ring, it's probably made of nickel or rhodium or something like that. Let's look for nickel. Nickel is, where are you? There it is, much higher. So this is more likely to oxidize. You pay a lot of money for gold because it does not oxidize. It's the bottom of the list. It is least likely to oxidize. I want to make sure my jewelry is least likely to oxidize. And right above that, Ag, which is silver. So gold and silver there at the bottom, they are the least likely to oxidize. So that is why they are usually not spontaneous oxidizers. All right, let's do another example so that I make sure you are confident in doing this. All right, let's say I have TiO plus Ni. I would get NiO plus titanium. Here titanium must have been a +2 and here it's a 0. And here nickel is a 0 and here nickel must be a +2 because I know oxygen's a -2. So nickel was oxidized and titanium was reduced because the one that's oxidized, the charge went up, and the one that is reduced, the charge went down. So to see if this is spontaneous or not, I need to see if Ni is higher than Ti. So I go back to my chart. I look for them. Here's Ti and here's Ni. So this reaction would not be spontaneous because Ni is not higher than Ti on table J. All right, let's move along. Let's move to the other side of table J. The other side of table J has nonmetals, and nonmetals want to reduce. So let's say I have a reaction where there are two nonmetals. Like let's say I have oxygen gas plus hydrochloric acid. What I would get is H2O, water, from putting the H and the O together, and I would have chlorine gas. All right, let's do our charges. Here, this is a +1, and here it is still a +1. Cl is a -1 here, and it's a 0 here, and oxygen is a 0 here, and over here it's a -2. So what went up in charge? Cl did. It went from a -1 up to a 0. And what was reduced in charge? Oxygen. Now, for nonmetals, I want the one reduced to be higher. So I want to look on table J and I want to make sure O is higher than Cl. If O, the one being reduced, is higher than the one being oxidized, then this would be spontaneous for this reaction. So let's go to table J. Let's look over here. O isn't even on there. So because O isn't on there, you assume that O is lower than the 4 that are listed, which means that this reaction, O is not going to be higher than Cl. So this reaction is not going to be spontaneous. This reaction would only happen with an input of energy. Let's do another one with nonmetals. Let's say we have F2 plus TiCl2. We would get TiF2 and Cl2. All right, here this is a 0, and over here it was a -1. Here this is a 0, and over here it's a -1. So oxidized, whose number goes up, chlorine's does. Chlorine goes from a -1 up to a 0, and the one reduced going down is F. It's going from a 0 to a -1. I want the one being reduced over the one being oxidized, so I want F to be over Cl. Now I go back to table J. F is higher than Cl. So this reaction would be spontaneous, which means this reaction would happen without any input of energy. All right, what you guys are going to work on this week to sort of change it up a little bit, make it a little fun, we found a really cool simulation. So there is a worksheet, and the worksheet has you go through problems like what I just did, and then it has you access a computer simulation. And the computer simulation shows you different solutions. And so in the solutions, let's say I have MgNO3 2. So I add a metal into this. So here's a piece of metal like K. If I add K into here, think about the reaction I'm doing. K plus MgNO3 2. I would expect the K to react with the NO3. K is a +1, NO3 is a -1, so that product is just KNO3. And then magnesium would now be alone. To balance it, I would need 2 of those and 2 of those. Magnesium is going to go from a +2 down to a 0, so it's reduced. And K went from a 0 to a +1, so it's oxidized. So oxidation, reduction. The one that went up in charge was K. The one that went down in charge was Mg. These are both metals, so I am expecting K to be higher than Mg. I go back and I look at my table. There's K, there's Mg. It is higher. So this reaction is spontaneous. When you run the simulation, you are going to see that this starts bubbling and reacting, and it's probably going to change color as it oxidizes. So this reaction is going to be spontaneous and will happen. You're going to put them in different solutions. So as long as K is higher than the solution you put it in, it should oxidize. All right, if I put K in LiNO3, that would be not spontaneous, because I remember I talked about a cell phone battery. Li was at the top of the list. So Li is definitely not under K, so that would not react. So you get to do the lab, put the metals in the different solutions, and figure out if the reaction was spontaneous or not. Make sure you write down any questions that you have, and I will be happy to go over anything that you would like during our Zoom on Friday from 12 or 1 to 2. All right, bye guys. Miss you.